Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals x cubed minus 9x squared plus 24x minus 10. The first thing to do is find the domain. F of x equals x cubed minus 9x squared plus 24x minus 10, which is a polynomial, and the domain of a polynomial is all reals, or negative infinity to positive infinity. The next thing to do is find all critical numbers. We will take the first derivative, f prime of x, which equals, first term is power rule, bring down power, subtract 1 from it. Second term is power rule, bring down power, multiply with the negative 9, subtract 1 from it. Third term is constant times x, derivative is the constant. Fourth term is a constant with no x, derivative is a 0. We now will fully factor the derivative. There's a common factor of 3. Factoring that out, we'll leave behind x squared minus 6x plus 8, which is a trinomial quadratic, and can further factor into x and x. We need two numbers that multiply to be a positive 8 and add to be a negative 6. They need to both be negative. Negative 4 and negative 2 will take care of this. We can now set the numerator equal to 0 and the denominator, if there is one, also equal to 0 and solve for all x's. This will result in x equals 4 and x equals 2. We will now check to see whether these are in the domain. The domain is all real numbers, negative infinity to positive infinity. X equals 4 and x equals 2 are both real numbers. They're in the domain. They are both critical numbers. The next thing to do is draw a domain line. The domain is negative infinity to positive infinity, so it will not have a left end or a right end. We can put the critical numbers on the domain line. 4 is greater than 2, so it will end up to the right of 2. We can now pick test values in each of the intervals created by the critical numbers. The interval negative infinity to positive 2 contains 0. I will pick that as the test value. The interval 2 to 4 contains 3. I will pick that as the test value. And then the interval 4 to infinity contains 10. I will pick that as the test value. Each of these test values can be plugged into the first derivative to test the trend in each of the intervals. It only matters whether it is positive or negative here, not the actual value. So the best place to plug these in will be the factored version. Starting with the 0, plugging into the factored version, 0 minus 4 is a negative, times 0 minus 2, which is also a negative. A negative times a negative is positive, times a positive 3 is a positive. The first derivative is positive in this interval, and that corresponds to an increasing trend. Now we can plug in the test value of 3 into the factored version of the derivative. 3 minus 4 is a negative, times 3 minus 2, which is a positive. Negative times a positive is negative, times a positive 3 is still negative. The first derivative is negative in this interval. That corresponds to a decreasing trend. We can now plug in the test value of 10 to the factored version of the first derivative. 10 minus 4 is positive. 10 minus 2 is also positive. Positive times positive is positive, times a positive 3 is still positive. The first derivative is positive in this interval. That corresponds to an increasing trend. So we have an increasing trend happening from the interval negative infinity up to positive 2, and again, so union, from 4 to positive infinity. And we have a decreasing trend happening from 2 to 4. The trend changed at the critical number of 2 and again at the critical number of 4. At the critical number of 2, it changed from increasing to decreasing. That means the critical number of 2 will be a relative maximum. And we can find a corresponding y-coordinate by plugging the x value into the original function. F of 2 will be 2 cubed minus 9 times 2 squared plus 24 times 2 minus 10. 2 cubed is 8. 2 squared is 4 times the negative 9 is a negative 36. Plus a 24 times 2, which is a 48, minus 10. 8 minus 36 is a negative 28. Plus 48 will be a 20, minus 10 will be a 10. So we have a trend change from increasing to decreasing at that critical number, and that will correspond to a relative max. It has an x-coordinate of 2 and the y-coordinate of 10. We also have a trend change at the critical number of 4. It's changing from decreasing to increasing. That will be a relative min. We can find the corresponding y-coordinate for that critical number by plugging the 4 into the original function, which will equal 4 cubed minus 9 times 4 squared plus 24 times 4 minus 10. 4 cubed is 64. 4 squared is 16 times a negative 9 will be a negative 144. Plus 24 times 4 will be a positive 96, and then minus 10. 64 minus 144 will be a negative 80. Plus 96 will be a 16, minus 10 will be a 6. So we have a change in trend from decreasing to increasing. That will correspond to a relative min. It has an x-coordinate of 4, and we found the y-coordinate corresponding to it to be a 6. So we have a relative max at 2, 10, and a relative min at 4, 6.